So, good morning, dear students. Welcome to image processing class. Okay. So, as we have made few discussions on run length coding, in particularly in order to handle the image compression. So, we will continue this process of image compression using sub-image selection concept. So, today's topic is sub-image selection, and for this purpose, also once again, the concept of run length coding can be deployed. Okay. So, with all this, I'm going to start the presentation. So, I'm going to explain the concept with the presentation. Kindly go through it. Okay. Yes. Can you see this PPT, dear students?
Yes, sir.
Okay. So this is what we have yesterday made some discussions on run length coding. Okay. So this run length coding can be established by identifying a suitable dynamic range, provided that a given pixel values, gray level values have been provided and a window range has been given. We have to evaluate the run length code and run length and as well as the gray level code. So this is what we have already, we have can find out this in my previous class. We have discussed all these things, isn't it? Any doubts here in this problem? Have you understood?
Yes, sir.
Okay. So this is what the original image, if you consider this image original image, if you apply the dynamic window range using the run length coding mechanism, how the image is going to change. For example, if this is the original image and if you choose window length of 10, so in our previous case, we have taken window range of 5 and we have applied the compression. Next, in this case, suppose if the window size is 10, the compression is 4:1, means if 4 is the 4 times the given image will be compressed. Okay, so that is the compression ratio. Then, so error image of B, so this is the E, and this is the error image of B multiplied show detail, means if you just highlight the histogram of this image, you can minutely see the difference over here. Okay, you can see so this is called as an error image. Okay, so this image is used to identify the variations in the image. Like for example, if these counters, okay, you can identify these counters here also. Okay, so you can also consider this as a segmentation also. Okay, so here also you can see more and more details here compared to the window size 10. If you vary the window length size to 35, the compression is 8:1, means 8 times the given image will be compressed, and this will be the compressed image. What we can see, this is a compressed image. So this is not in a format we can see it. Okay, the data has been encoded over here, and we can see a little bit of contents you can see here. So similarly, this is a window size of length of 60. Okay, so here also you can notice the minute changes or details in the compressed image. So in general, if you want to consider, this algorithm uses some pre-processing. Okay, so because once you compress the image and once you decompress the image, the retrieved image, the decompressed image will be of a little bit less in terms of quality, because this is a lossy image compression. So what happens in lossy image compression? To some extent, you have to compromise, you have to make a trade-off with respect to the quality, isn't it? So the quality will be a little bit reduced. So this can be overcome by using some standard pre-processing mechanism, and these are nothing but our what we can say image enhancement technique. Okay, so the mapping coding can be used for this purpose. Okay? Hello. Yes, yes, students. Shall we continue?
Yes, sir.
Fine. So under this, the run length coding, the next concept, today's concept we have to discuss, the blocking mechanism. Okay. So remember the side heading barcoding, blocking or block truncation coding. So it is same. Block truncation coding antrunu onda, blocking antrunu onda. So this can be used to achieve the image compression using sub-image selection. Okay. So this is the definition of this block truncation coding. Okay, so what is this block truncation coding? So this is a mechanism in image processing techniques. It is used to compress the given image by using sub-image selection concept. Okay, so the block truncation coding or blocking, so block truncation coding, it works by dividing the image into smaller sub-images. Now, one image is so our image na sub-image agi decompose ಮಾಡ್ತೀವಿ, divide ಮಾಡ್ತೀವಿ. For example, 2x2 or 4x4. 4x4 means 4 rows and 4 columns. Okay. So and reducing the number of gray levels in the each block. ಪ್ರತಿಯೊಂದು block ಅಲ್ಲೂ ಕೂಡ ನಾವೇನ್ ಮಾಡ್ತೀವಿ? We are going to reduce the gray levels. If there are more number of gray levels, you try to reduce the number of gray levels so that the storage consumption of the image will be reduced. Okay. So that these gray levels are reduced by a quantizer. So how this can be achieved? This can be implemented by using a standard mechanism of quantization. Quantization, already we heard the sampling, but the quantization. The sampling is the digitization of an analog signal. Quantization is nothing but dividing the given gray levels into different zones. Okay, so we can reduce the number of the different levels of gray levels into one particular band. So this is called as a quantization. So using this quantizer, we are going to reduce the number of gray levels. Okay. Next, the levels of the quantizers are chosen. Okay, this can be identified. The levels can be identified in order to minimize the error criteria. If there is any kind of errors, means if there is any kind of bugs or it may be something which is not normal. So in those scenarios, we have to identify the level of quantization so that we have to overcome the error criteria. And then all the pixel values with each blocks are mapped to the quantization level. Means once we have identified the pixel values or gray level values, assign them to the appropriate band using the levels, that is quantization levels. Next, the necessary information to decompress the image is encoded and stored. This is also very, very important. Before we are going to decompress or before we are going to compress, we have to store some related information related to the image, like how much coding, how much encoding is done. So what is the storage required before encoding or compression? What is the storage required after compression? So these kind of information has to be stored somewhere else. Okay. So the basic form of BTC, that is block truncation coding. Example, discuss BTC. ಅಥವಾ blocking ಅಂತಂದ್ರೆ it is nothing but block truncation coding. So ಏನ್ ಮಾಡುತ್ತೆ ಇದು, it is going to divide the image into n cross n blocks, ಅಂದ್ರೆ n into n different blocks ಆಗಿ divide ಮಾಡುತ್ತೆ and codes each block using a 2-level quantization. So the 2 levels are selected so that the mean and the variance of the gray levels are preserved. So why we have to go for 2-level of this quantization? Because so in the first level, we are going to find out the mean of the given gray level, okay, or given block or given sub-image. Next, variance. Mean and variance are the statistical formulas or statistical mechanism through which we can identify the given value of the particular block. So mean is just like an average. Variation is just like a standard deviation. I think you people have studied all these things in the mathematics. So next. Each pixel values with the block is then compared with a threshold. We have to always find out a threshold. Threshold means peak value. For example, if you consider an 8-bit image, the 255 will be the highest white, so called as a threshold. We cannot exceed that, no? So that is called as a threshold. So typically the block mean and the block and then is assigned to one of the levels. So wherever there is a highest value which is closer to the threshold, we have to assign the mean values. Next, if it is above the mean, it is assigned as a high level code. Suppose if the threshold value will be taken as a mean, if the value is higher than the mean, it will be taken as a high level code. On the another hand, it will be taken as a low level code. So we have to take a margin here. Okay, the margin is a mean. If the given value of the gray level is more than mean, you consider this as a high level code. Okay, or if the value of the gray level of the pixel is less than the mean of the given sub image or a block, you just store that value under low level code. So either theory is to some, it is a little bit difficult to understand. So that is why we will take a problem for this. Okay, then you can easily understand how this mean and variance can be used to find out the threshold value, and as well as how it can be assigned above and below. Okay, so these are some of the standard formulas what we have to use in order to solve the problems. Okay, if we call the high level value as a h, okay, so the capital H will be considered as a high level value, and capital L will be declared as a low level value, and we can find out the following equations. So these are some of the equations, or what we can say the formulas through which we can find out the H. H means, anybody? H andre enu? It is here only, no? High value. L means?
Low value.
What is L?
Low value.
Low value. Next. So we have to choose the block size. Okay. It is, in general, it will be given as n cross n. So it may be generally adana 4 cross 4 tavathivi, 8 cross 8 tavathivi. So that is what we have to choose. Next, B is the current block. Our block now that is considered as B. So MB is nothing but the block mean. Okay, block mean is given by 1 by n square into summation of L of R comma C. L means gray level value, R means row, C means column. Okay. Similarly, so this is given as a gamma. Okay, so gamma is nothing but the variance. Okay, the block variance, which is given by square root of 1 by n square summation of gray level L, R means row, C means column, square, minus MB, that is MB means block. Okay, so this is block. Okay, block mean. So this block mean, whatever we have evaluated, that will be substituted in the block variance, that is gamma. Okay, next Q will be considered as, because Q we have to substitute here. Okay, somewhere here. So Q will be considered as the number of values in the block, which is always greater than MB. MB means block mean. So these are the standard formulas. You have to note down these formulas. So only one can solve the problems. Definitely you will get the problems in the exams. So please be careful. Note down these formulas. Okay. The formulas use not going to new next to problems or not. Okay. Shall we go for the problem then?
Yes, sir.
Okay. So now, if n is equals to 4, what is the block size? The block size will be 4 cross 4. Okay, it is a 4 cross 4 with suitable H and L, that is high value and low value have to be evaluated and has to be encoded with 4 bytes because it's a 4 cross 4 block. Next, 2 bytes are stored. Okay, 2 bytes are stored. 2 levels, that is H and L. Okay, one is for H means high value and L for low value, and 2 bytes are required to store a bit of string of ones and zeros, because when you are encoding a given block, we are encoding a given block, you have to code them using binary codes, and the binary codes, they are of course 1 and 0. So now we will take this diagrammatic representation of the blocking or subimage selection through the block truncation coding. So this is the image. Okay, this is the image, and we have divided this image. We have to divide this image into 4 cross 4. So if you consider this image, we have divided. We have made a grid on this. Okay. So next we have to find each block. Pratiyondu block na tagoli ಆ ಬ್ಲಾಕ್ ಅನ್ನು 4x4 ಆಗಿ ಡಿವೈಡ್ ಮಾಡಿ. ಮೀನ್ಸ್ 4 rows and 4 columns have been divided, and we have to find out the high value and low value. ಇವೆರಡನ್ನು ಕೂಡ ನಾವು ಒಂದೊಂದು ಬ್ಲಾಕ್ ಅಲ್ಲೂ ಕೂಡ ಕಂಡುಹಿಡಿಯಬೇಕು. For example, this block 1, block 2, block 3, block 4, block 5, block 6. And in each block, you have to find out the high value and as well as low value. Once you have identified the high value and low value, you assign the zeros and ones for it. So how to assign zeros for high value, how to assign 1 for low value, that I will explain in the next PPT. Okay. So next we have to align them. Okay, encode them into 4x4 block with 4 bytes. So this is row 1, this is row 2, this is row 3 and row 4. So this is high grade level value, low grade level value. So this is the general representation of the basic block truncation or blocking, what we can say sub-image selection. Now this is the problem. You consider, all of you, percoding problem. Given the following 4x4 sub-image, apply BTC or blocking, that is block truncation coding, and find the resulting values. Okay, shall I explain?
Yes, sir.
Fine. So ನೋಡಿ ಆಮೇಲೆ ಬರ್ಕೋತಿರಂತೆ, ಕೇರ್ಫುಲ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಎಲ್ಲ. ನಿಮಗೆ ಈ ತರ ಒಂದು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ. Given the following 4x4 sub-image. ನೋಡಿ 4x4 ಅಂದ್ರೆ how many rows, how many columns? There are 4 rows here and there are 4 columns here. Okay. And apply the BTC, that is block truncation coding. B and the block, T and the truncation, C and the coding. Athava blocking, sub-image selection. So block truncation coding. Find the resulting values. First, now you are going to mean ಕಂಡುಹಿಡಿಯಬೇಕು. Once ನಾವು mean ಕಂಡುಹಿಡಿದ ಮೇಲೆ we shall go for variance. So what is the formula for mean? MB means block mean is equals to 1 by n square into summation of grade levels of all the summation of the grade levels. So what is n here?
4.
4, because n cross n is 4. So 1 by n square. So 1 by n square and 1 by 4 square. 4 square and rest to
16.
16. Next what is summation. Summation of all the grade levels, right from 12 to 12. So first value is 12, next value is 16, 15, 17, 13, 16, 17, so on up to 42, 12, 12. ನೋಡಿ ಎಲ್ಲ grade levels ಏನು ಮಾಡಿದೀವಿ ಅಲ್ಲಿ summation ಮಾಡಿದೀವಿ. ಹೌದಾ? So what is the total of this? ನೋಡಿ ಮಾಡಿ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಥವಾ ಮೊಬೈಲ್ ಅಲ್ಲಿ ಇದು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿ, ವೆದರ್ ಇಟ್ ಈಸ್ ಸೇಮ್ ನನಗೆ ಹೇಳಿ ನೋಡೋಣ. ಮಾಡಿದ್ರಾ? Have you done? Just verify the values. Just sum up 12 plus 16 plus 15, and you whatever the sum comes now, you divide it by 16. Have you obtained the results?
Yes, sir.
Fine. Have you got the same answer? 19.3125?
Sir.
Okay, fine. Thank you. So next, after once the mean has been evaluated, now we shall go for the variance. Okay. So once again, the formula for the variance is square root of 1 by n square into summation of the grade levels minus mp square. That is what we have evaluated here. 19.3125. That has to be substituted. Square mb square. Once again, you substitute n. Of course, we know n is 4. 1 square root of 1 by 16, because n square 4 square is 60. And once again, the summation of all this. That is, this is a square. Okay, here only the value should be taken here. The square of the grade levels, because every value will be square. 12 square, 16 square, 15 square. Everything will be square. So the summation will be it will be subtracted from 19.3125 square. That is the mean, block mean. Okay. So when you do this, 11.85 you are going to get. Okay. So you can do this later on also. You can verify this. So next we shall continue. Shall we continue?
Yes, sir.
Yes.
Yes, sir.
Okay. ಇಲ್ಲಿ ಏನಾರ ಡೌಟ್ ಇದೆಯಾ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ?
No, sir.
Okay. So till then ಈ ಸ್ಟೆಪ್ ವರೆಗೂ ಅರ್ಥ ಆಗಿದೆ ಅನ್ಕೊಂಡು ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಗೆ ಹೋಗ್ತಾ ಇದ್ದೀನಿ. Fine.
Yes.
Fine. So next ನಾವು ಇವಾಗ ಏನ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ we have to find h and l. ನಾನು ನಿಮಗೆ ಹೇಳಿದ್ದೆ h is nothing but high value, l is nothing but low value. So ಈ h ಮತ್ತೆ l ಅನ್ನ we have to find out now. Okay. So there are 4 pixels values greater than the mean. So q is equals to 4. Okay. So q is equals to 4. ಯಾವ ತರ ನೀವು q is equals to 4 ಅಂತ ತಗೊಂತೀರಾ ಅಂತಂದ್ರೆ ನೋಡಿ, this is the formula. So there are 4 pixel values greater than mean. Okay, q selection ಮಾಡಬೇಕು ಇವಾಗ. So mean ಎಷ್ಟು ನಮಗೆ ವ್ಯಾಲ್ಯೂ ಬಂದಿರೋದು?
19.31.
Okay, ಈಗ ನೀವು ಈ mean ನ ಈ ಎಲ್ಲಾ ವ್ಯಾಲ್ಯೂಸ್ ಜೊತೆಗೆ ಕಂಪೇರ್ ಮಾಡಿ. How many of them greater than 19.3125? Whether 12 is greater than 19? No. 16 is greater than? No. 15 is greater than? No. 4 is greater than? No. 4 is greater than? No. Now what about the 35? Whether 35 is greater than 19?
Yes.
Next, this 35?
Yes.
Next 42?
Yes, sir.
This 42. So how many occurrences of the gray levels greater than mean?
4.
So that is why q is equals to 4. Got it?
Yes, sir.
Fine. Now you substitute all these values for h and l. h and l ಈ formulas ಇಲ್ಲಿ ಬರ್ತಿದ್ದೆ ನೋಡಿ. h and l ಜ್ಞಾಪಕ ಇದೆಯಾ? h and l. Okay. Substitute ಮಾಡಿ. So it is nothing but mb, that is block mean plus the gamma, that is variance, into square root of n square minus q by 4. So ನಮಗೆ mb ಗೊತ್ತು, mean ಗೊತ್ತು, variance ಗೊತ್ತು ಮತ್ತೆ n. n means that is the 4 and q just we have identified now. So substitute ಮಾಡಿ. mb is 19.3125, variance, block variance is 11.85. ಈಗ ತಾನೇ ಬಂದಿದೆ ಇಲ್ಲಿ ಇದೆ ಇದು. Okay. Next, into square root of n square. N is 4. 4 square is 16 minus q, that is 4. 16 minus 4 all divided by once again q, that is 4. So you solve ಮಾಡಿದ್ರೆ ನಿಮಗೆ approximately 40 ಬರುತ್ತೆ. ಚೆಕ್ ಮಾಡಿ ನೋಡೋಣ whether you are getting same thing. Just evaluate 19.3125 plus 11.85 into square root of 16 minus 4 by 4. How much you have obtained? Just make the calculations. Don't sit idle, just keep on listening. Do some activities, then only you will be more and more active and you will understand also in a better way. That is why I am requesting you to kindly solve this. Use your pen and paper. Just use your mobile calculator. Anybody solved? Yes? Anybody? Obtain the result. Yes, dear students, ಮಾಡಿದ್ರಾ? Come on. Sixteen minus 4 is 12. 12 by 4 is 3. Square root of 3 into 11.85 in plus 19.3125. ಹಂಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಮಾಡಬಹುದು ನೋಡಿ. Square root of 3 ಎಷ್ಟಪ್ಪ?
1.732.
Square root of 3 is 1.73. Very good. Into 11.85. ಎಷ್ಟು ಬಂತು? 20.52 ಬಂತ? 20.52 plus 19.3125. 39.83 ಬರುತ್ತೆ ನೋಡಿ.
Yes, sir.
39.3 ಅಂದ್ರೆ it is approximately equal to 40 ಅಲ್ವಾ?
Yes.
Okay. Dear students, are you engaging yourself or not? Come on. Approximation 40 banta ellargu. Okay. Next, similarly, we are going to find out the low level value or low value, which is nothing but MB, that is block mean minus variance into square root of Q divided by n square minus Q. Okay. Now here, once again, you substitute the block mean, that is 19.3125 minus 11.85 into square root of 4 by 16 minus 4. So what is 16 minus 4? 16 minus 4 is 12 alva. Howdu alva?
Yes, sir.
So 4 divided by 12 andre 1 by 3. Sarina? Sariyanappa?
0.3.
1 by 3 barutte. So 1 by 3 is nothing but 0.3. So square root of 0.3 ಏನಪ್ಪ? Square root of 0.3 is 0.57 alva? Banta? 0.7 into 11.85. Okay, 11.85. It is nothing but 6.83 and 6.83 minus 19.3125 is equals to 12.47 ಏನೋ ಬರುತ್ತೆ. 12.4743209, which is approximately equals to how much? ಬೋರ್ಡ್ ಮೇಲೆ ಮಾಡ್ಬೇಕೇನಪ್ಪ ಇದು?
13.
13 ಅಲ್ಲ, ಬೋರ್ಡ್ ಮೇಲೆ ಏನಾದ್ರು ಮಾಡ್ಬೇಕೇನ್ರಪ್ಪ? ಹಲೋ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್.
No, sir.
ಓಕೆ, ಒಂದು ನಿಮಿಷ. ಕ್ಲಾಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ನೋಡಿ, ಈಗ ನಮಗೆ h ಮತ್ತೆ l ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಿದಿದ್ದೀವಿ. ಓಕೆನಾ? ನಾವು ಫೈಂಡ್ ದ ಬಿಟ್ ಸ್ಟ್ರಿಂಗ್. Okay, so now find the bit string by using 0. ನೋಡಿ, ಈಗ h and l ಎಲ್ಲರಿಗೂ ಗೊತ್ತಾಗಿದೆಯಾ dear students?
Sir.
Okay, fine.
Yes, sir.
Now find the bit string by using 0 for values less than mean and 1 for the greater than mean. ಅಂದ್ರೆ ಈಗ ನಾವು mean value ಏನಿದೆಯಲ್ಲಪ್ಪ ಈ 19, this is the mean. Okay, ಈ mean value ಏನಾರೆ this is the actual image. ನೋಡಿ ಇದು actual image. ಈ actual gray level values mean ಗಿನ ಕಡಿಮೆ ಇದ್ರೆ ಅದನ್ನ 0 ಇಂದ ಎನ್ಕೋಡ್ ಮಾಡಿ. If the value is greater than mean, okay, then you encode with 1 ಅಂತ. ಲಾಜಿಕ್ ಅರ್ಥ ಆಯ್ತಾ? ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತೀನಿ, ಇದು ಒರಿಜಿನಲ್ ಇಮೇಜ್. ಎಸ್ ಆರ್ ನೋ?
ಎಸ್ ಸರ್.
ಇದರಲ್ಲಿ ಪ್ರತಿಯೊಂದು ವ್ಯಾಲ್ಯೂನು ತಗೊಳ್ಳಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 12, ಈ 12 ನ MB ಜೊತೆ ಕಂಪೇರ್ ಮಾಡಿ. MB ಎಷ್ಟು? 19.312. ಓಕೆ, ಸೊ ಈ 12 19.3125 ಗಿನ ಸ್ಮಾಲರ್ ಗ್ರೇಟರ್?
ಸ್ಮಾಲರ್.
ಸೊ ದೆನ್ ಯೂಸ್ 0. ಎಲ್ಲೆಲ್ಲಿ ಸ್ಮಾಲ್ ಇರುತ್ತೋ ಅಲ್ಲೆಲ್ಲ 0 0 ಹಾಕಿ, ಎಲ್ಲಿ ಕೋಡೆಡ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ. ಓಕೆ, ಸಿಮಿಲರ್ಲಿ ಸಪೋಸ್ 35 is greater than 19.3125. So that is why in place of 31 you have to substitute
1.
ನೋಡಿ, ಎಲ್ಲೆಲ್ಲಿ 35 42 42 11 ಇದೆ, ಎಲ್ಲ ಕಡೆನೂ ಸ್ಮಾಲರ್ ದ್ಯಾನ್ ಮೀನ್ ಇರೋದ್ರಿಂದ 0 0 0 ಆಗಿದೆ. So this will be considered like this. ಎಲ್ಲ zeros ಒಂದು ಅರೇ, ಸ್ಟ್ರಿಂಗ್ ಆಫ್ ಅರೇಸ್ ತಗೊಂಡ್ಬಿಟ್ಟು 2, that is in binary digits ಅಲ್ಲಿ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Okay, so the high value H and the low value L will be stored along with the bit string. The subimage C when decompressed will be. Okay, so ಇದನ್ನ ನಾವು ಯಾವಾಗ ಇದನ್ನ ಡಿಕಂಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ, ಸೊ ನೋಡಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ, ಸೊ ಎಲ್ಲೆಲ್ಲಿ ನಮಗೆ zeros ಇದೆಯಪ್ಪ, ಆ 0 ಇರೋ ಜಾಗದಲ್ಲೆಲ್ಲ, so 0 will be declared as what?
Low value.
So low value ಎಷ್ಟಿದೆ?
13.
ಸೊ 13 ಅನ್ನ ಹಾಕಿ. ಯಾವಾಗ ಡಿಕಂಪ್ರೆಸ್ ಮಾಡೋದಕ್ಕೆ, ಸೊ ನೋಡಿ ಇದು ಒರಿಜಿನಲ್ ಇಮೇಜ್. ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತೀನಿ, ಇದು ಒರಿಜಿನಲ್ ಇಮೇಜ್. ಈ ಒರಿಜಿನಲ್ ಇಮೇಜ್ ತುಂಬಾ ಸೈಜ್ ತಗೊಳುತ್ತೆ. ವಿ ಕ್ಯಾನಾಟ್ ಟ್ರಾನ್ಸ್ಮಿಟ್ ಡೈರೆಕ್ಟ್ಲಿ ದಿಸ್ ಒರಿಜಿನಲ್ ಇಮೇಜ್. ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಂಪ್ರೆಸ್ ದಿಸ್. ಸೊ ಯೂಸಿಂಗ್ the block truncation coding. So this is the compressed image using BTC code or blocking subimage selection. So this will be, it is going to consume less memory compared to original image. Yes or no? Because it is in binary digits. Yes or no?
Yes sir.
So this will be transmitted through the link. Once it reaches the destination, ಇದು destination ಗೆ ಬಂದಿದೆ. ಇವಾಗ ನಾವು ಅದನ್ನ ಡಿಕಂಪ್ರೆಸ್ ಮಾಡಬೇಕು, ಡಿಕೋಡ್ ಮಾಡಬೇಕು. ಸೊ ಯಾವ ತರ ಡಿಕೋಡ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ, if wherever there is a 0 value, that is low will be substituted. What is low value?
13.
So ನೋಡಿ, ಇಲ್ಲಿ 0 ಇದೆ, 0 ಇದೆಲ್ಲ 0 ಇರೋ ಜಾಗದಲ್ಲಿ 13 ಹಾಕಿ. Then wherever there is a 1, you substitute the high value. What is high value?
40.
ನೋಡಿ, ಎಲ್ಲೆಲ್ಲಿ 40 ಇದೆ, ಇಲ್ಲೆಲ್ಲ 40. 1 ಎಲ್ಲೆಲ್ಲಿ ಇದೆಯೋ ಅಲ್ಲಿ 40 ಹಾಕಿ. Now you compare this image. This is a decompressed image. This is original image. Any difference? Any difference between original image and decompressed image? Yes? ಏನಾರ ವ್ಯತ್ಯಾಸ ಇದೆಯಾ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದೀನಿ.
Yes sir.
Okay, minute differences ಇದೆ ತಾನೆ?
Yes sir.
ನೋಡಿ, ಇಲ್ಲಿ 12 ಇದೆ, ಇಲ್ಲಿ 13 ಇದೆ, ಇಲ್ಲಿ 16, ಇಲ್ಲಿ 13, 15, 13. ಅಂದ್ರೆ the values are closer. ನೋಡಿ, ಇಲ್ಲಿ 35 ಇದೆ, ಇಲ್ಲಿ 40 ಇದೆ, ಇಲ್ಲಿ 42 ಇದೆ ಅಂತ 40. ಅಂದ್ರೆ ಇದೊಂಥರ average image, ಇದು decompressed image. That is why we call this as a lossy image compression. Lossy ಅಂದ್ರೆ ಏನು? ಸ್ವಲ್ಪ ಡೇಟಾ ಲಾಸ್ ಆಯ್ತು ತಾನೆ ನಮಗೆ ಇವಾಗ. Yes or no?
Yes sir.
This loss can be overcome by using image enhancement or pre-processing technique. Got it?
Yes sir.
This is how we can apply image compression using BTC code, block truncation coding. Okay, so this algorithm tends to produce image with blocky effects, and ಅದಕ್ಕೆ ಇಲ್ಲಿ ನಮಗೆ ಸ್ವಲ್ಪ blocky effect ಬರುತ್ತೆ, ಸ್ವಲ್ಪ blur ಆಗುತ್ತೆ. These artifacts can be smoothed. ಇದನ್ನ ಸರಿ ಮಾಡಬಹುದು by using image enhancement, in particularly low pass and average median filters use ಮಾಡ್ಕೊಂಡು we can do that. Okay, so for example, ಇದು original image ಅಂದ್ರೆ, so ಇಲ್ಲಿ ನೋಡಿ block truncation code ಮಾಡಿದ್ದಾರೆ, compression 4:1. 4:1 ಮಾಡಿದ್ದಾರೆ. So this is the encoded image. Okay, so this is the encoded image, that is histogram stretched image. Similarly, ಇಲ್ಲಿ post processing ಮಾಡಿದ್ದಾರೆ. ಈ ಇಮೇಜ್ ಮೇಲೆ ಏನ್ ಮಾಡಿದ್ದಾರೆ, ಸ್ವಲ್ಪ ಲೋ ಲೆವೆಲ್ ಆವರೇಜ್ ಫಿಲ್ಟರ್ಸ್ ನ ಅಪ್ಲೈ ಮಾಡಿ ಸ್ವಲ್ಪ ಕ್ಲಾರಿಟಿ ಇಂಪ್ರೂವ್ ಮಾಡಿದ್ದಾರೆ. ದಟ್ ಈಸ್ ಪೋಸ್ಟ್ ಪ್ರೊಸೆಸಿಂಗ್. ಅಂದ್ರೆ ಆಫ್ಟರ್ ಇಮೇಜ್ ಹ್ಯಾಸ್ ಬೀನ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್, the next process is called as a post processing enhancement technique. So this is also post processing with 3x3 average filter. This is median filter. So ಇಲ್ಲಿ median filter ಅಲ್ಲಿ ನಮಗೆ ಜಾಸ್ತಿ ಕ್ಲಾರಿಟಿ ಇದೆ. average ಅಲ್ಲಿ ನೋಡಿ ನಿಮಗೆ ಎಲ್ಲ ಇಟ್ರಿ ನೋಡಿ ಎಲ್ಲ ಕೂಡ ಬ್ಲರ್ ಆಗಿ ಕಾಣ್ತಾ ಇದೆ. ಈ ಬಿಲ್ಡಿಂಗ್ ಕೂಡ ನೋಡಿ ಇಲ್ಲಿ ನಮಗೆ ಈ ಕಡೆ ನೋಡಿ ಇಲ್ಲೆಲ್ಲ ಸ್ವಲ್ಪ ಬ್ಲರ್ ಇದೆ. So this is how the multi-level block truncation algorithm with quantizer we can use in order to compress the given image. So this is multi-level block truncation coding. This is also we can do. So these are some of the diagrams, the results of applying this multi-truncation coding. Now ಮಾಡಿರೋದು single level ಮಾತ್ರ. This is multi-level. So according to your syllabus, only block truncation has been given. Multi-level ನಿಮಗಿಲ್ಲ, but ಸುಮ್ಮನೆ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ. Okay. So this is all about blocking and sub-image selection and block truncation coding. If you have any queries, dear students, you can ask me now. Okay, shall we stop here then?
Yes, sir.
Okay, dear students, thank you so much for joining image processing session. I request all of you to give your attendance through the chat box if anybody have not given. So please take care of yourself and complete your assignment and submit as early as possible. Maybe within 3 or 4 classes, our syllabus is going to be exhausted, completed. So we are at the end of the syllabus, maybe 1 or 2 concepts remaining. Okay. So with all this, I'm going to stop my class. Thank you so much for joining.